Hi friends, welcome to our channel. This is Kishore Palavalsa. Today we are going to discussing about range of extension. Here the range of extension can be doing for both ordinary DC voltmeters as well as DC ammeters. So if you want to use for those ordinary meters can be used for high voltage as well as high current profiles, we must should be extension in the range of those two meters. Okay, how can we extension? Do you know? So here the extension can be basically possible with the help of network elements. One is the resistance. Okay, so by the connection of resistance, both series as well as parallel to the both ammeters as well as voltmeters, we can use that high profile range. For ammeter, okay, construction point of view, for example, input we are giving like DC supply plus minus. So here ammeter is there like this. So for example, if you want to increase the profile of range of ammeter, we must should be connected these resistor across the both two terminals of ammeter, then only we can increase the profile range of current of ammeter. If you want to go for voltmeter construction point of view, so this is voltmeter. So this voltmeter can be connected in series with the resistance. Okay, here we are giving input of DC supply. So like this construction, we can improve the voltage profile of a range of voltmeter. Okay. Like this, we can extend the range of both ammeter values as well as voltmeter values with the help of both series resistance as well as parallel resistance. Keep that point very important. Okay, so if you want to improve the voltage profiles in terms of kilovolts, like that, we must should be increase the number of parallel resistance at the ammeter as well as number of series resistance at the voltmeter. Like that, we can use it as high range profiles with the help of ordinary those two meters. Okay, now coming for the DC ammeter expression, which is given by, this is the ammeter diagram representation. So across the ammeter some resistance is there. Okay, here the input supply which is here given as like DC supply, that is given as VDC, and also across the ammeter some shunt resistance is there. So the current flowing through the shunt resistance which is given as ISH. Basically this is resistance that is given as R. So which is connected across, that's why which is given as RSH. Okay, at the same time the current flowing through the meter. So like this is ammeter. So the current flowing through the meter which is given as IM. So by equalizing the voltage drop across the resistance as well as voltage drop across the meter, then only we can finally find out the shunt resistance. According to Ohm's law, V is equal to IR. So that's why ISH into RSH equal to. So from this meter IM into RM, that is given as here. So from this RSH is equal to R is equal to V by I. Already we know that RSH is equal to IM RM by ISH here. So from this diagram, the current flowing through the resistance as well as meter which is given as I is equal to sum of total current I is equal to the combination of ISH plus IM, that can be we are represented here. So from this equation we can calculate as ISH equal to I minus IM according to from this equation. So this ISH value can be substituted in equation 1. We can get into the shunt resistance value RSH equal to IM into RM by, here ISH nothing but I minus IM. Okay, so if you want to simplify this equation, we can finally get into the shunt resistance value. RSH is equal to RM by I by IM as minus IM by IM. We can simply represent like this. This RM here putting like this. This IM can be putting into downwards minus IM by IM like that. Okay, so IM gets cancelled. Finally we can getting into the RM by I by IM minus 1. If suppose I by IM is equal to small m, okay, so this here m, so here m is the multiplication factor. Okay, so therefore we can represent as RS is equal to RM by m minus 1. So this is the value of shunt resistance in case of ammeter. Okay, if you want to add this shunt resistance value to the ordinary ammeter, then only we can use that high profile range of currents. Okay, next we are going to derive the expression of voltmeter. So here the resistance which is current in series of voltmeter, that's why which is called as series resistance, that is given as Rs. Meter which contains some internal resistance, that is given as R. So it is like meter, that's why you can simply represent as Rm, as well as the current flowing through the meter which is given as Im. Okay, here input supply which is given as like DC. Now calculate the total voltage drop across the meter. So here series resistance as well as meter resistance both are in series, that's why we can simply written as Rs plus Rm. Okay, the product of the total current flowing through the meter into sum of total individual resistance. Okay, so that is given as expression like this. Okay, here the total voltage applied to the circuit, that is given as V. So V is equal to current flowing Im into Rs plus Rm. So by multiplying into Im to the overall entire resistance, okay, Im into Rm plus Im into Rs. So this is the total equation. And also here, so from this equation, ultimately what we have to calculate? Series resistance. That is the main point. Remember that. Okay. Here Rs equal to V by Im minus Rm. So this equation can be further dividing by the Rm at both sides. Then only we are getting like this. So here Rs by Rm equal to V by Im into Rm minus Rm by Rm. So here dividing by the Rm to the entire equation. Okay. So here Rm gets cancelled. So finally we are getting Rs by Rm equal to V by Im into Rm minus 1. Okay. So let us consider if we want to Im into Rm equal to small v, like that considering. So then only we are getting Rs by Rm equal to V by, so this is given as small v minus 1. Okay. Simplify here. V by small v equal to 1 plus Rs by Rm. So here 1 plus Rs by Rm is the multiplication factor for the voltmeter. Remember that point. Okay. So therefore M is equal to 1 plus Rs by Rm. So according to from this equation, if you want to multiply M into Rm equal to 1 plus Rs. So from this equation, finally Rs equal to M minus 1 into Rm. So this is the series resistance value for the DC voltmeter. Okay, so this is the class regarding today for extension of range of both voltmeter as well as ammeter. By adding the both multiplication factor for DC voltmeter as well as ammeter, we can use the high voltage profile ranges. Okay, so this is the total entire range of extension of meters. Okay, next class we are going to discussing about a new topic. Let's see that. Don't miss it. Thank you.